All right, so let's learn how to figure out what the 2D structure for a molecule is going to be. Now we're going to go through these steps here as we work through these first three examples. So I'm going to do step 1 for each of the three examples, then I'm going to come back and look at step 2 and so forth. So the first step is always to determine the total number of valence electrons that all the atoms in the molecule will share. Remember, there's no metal saying, hey, here, take my electron. That doesn't exist. So these nonmetals can't get their octet by accepting or gaining electrons. Instead, they're going to put them together and share because they're all in the same boat. They're all missing a few electrons and they don't have that octet. So they're going to take what they have, they're going to pool them together, and they're going to share them. So that's the first thing you have to do. Figure out how many they're each going to share. So let's look at the first formula. It's Cl2. Nice and simple. 2 chlorines. The next one is going to be a little bit more complicated. There's 3 atoms. And the next one, we got 5 atoms. 1 carbon and 4 fluorines. So let's see how we do this. The first thing you do is you look at the formula and you figure out who's in the molecule. Well, we got chlorine. And then you write down how many. The number sign means how many. Well, there's 2 chlorines. In this molecule, there's hydrogen and sulfur. So there's H and S. And you write down how many. The 2 tells you there's 2 H's, and the imaginary 1, because we don't see a number, we assume it's a 1, that tells you there's 1 sulfur. And then the last one in this page, we see CF4. So we got carbon and fluorine. There's no number here, so we assume it's a 1. And the 4 means there's 4 fluorines that are going to pool electrons with each other and with this 1 carbon. So that's the first thing you do is look at the formula and figure out how many of each element there are. Then you've got to figure out how many valence electrons they each have. And then you do some simple math. So we got to use our periodic table. We got to find chlorine and figure out valence electrons for chlorine. Now, here's chlorine. The valence electrons, remember, is just the number of electrons in the outermost energy level. So chlorine is in group 17, which means it's going to have 7 valence electrons. So we know there's 2 chlorines. They each have 7. 2 sets of 7 is 14. So these guys are going to share 14 electrons. Now we got 2 hydrogens and 1 sulfur. What are they going to share? Well, let's go to the periodic table, find hydrogen. Here's hydrogen. Hydrogen, you're just going to end up remembering it's got 1 electron. 1 valence electron, 1 total electron. So each hydrogen has 1, and there's 2 of them, so it's going to be 2 times 1. 2 times 1 is 2. Now what does sulfur have? Sulfur, we find sulfur over here. It's in group 16, so it's got 6 valence electrons. So 1 times 6 is 6. So the 2 hydrogens each have 1. The 1 sulfur has 6. Put that all together, get the grand total, they have 8 electrons. And the final example, we got carbon and fluorine. So let's find carbon and fluorine. Here's carbon. It's got 4. So remember, carbon is 4. And fluorine is in group 17. Fluorine is going to have 7. So you got to remember that. Carbon's 4, fluorine's 7. So let's go back here. Carbon has 4, fluorine has 7. And let's do the little math. There's only 1 carbon, and it's got 4. 1 times 4 is 4. Each fluorine has 7, and there's 4 of them. 4 times 7 is 28. Add them up to get the grand total, and you get 32. This is the highest number that you're ever going to get. If you get more than 32 with the examples that we do in this class, you're doing something wrong. All right, so it took a little while because we did 3 examples and I gave you some background as we were talking about it. But the first thing you always have to do is use a periodic table. You can't do this without a periodic table unless you memorize what group everything's in. But you got to use a periodic table to determine the total number of valence electrons that all the atoms are going to share. So you got to add them all up and get the grand total. Now the next thing you do is you're going to look at some pictures that one of which is the correct answer. But you're going to have to pick which one is correct. And this is the way you do it. Check to see that all the atoms in the pictures have an octet. If you find that something doesn't have an octet, cross it off. It's wrong. Don't even look at it. You need to know what an octet means. Now, if you're hydrogen, you only need 2. That's an exception. That's your version of an octet. If you're hydrogen, you're happy with 2. Because remember that 288 business? That first energy level can only hold 2. And hydrogen only needs that first energy level filled. So hydrogen needs 2. So single bonds, remember single bonds are 2 electrons. Remember, it's a pair of electrons zipping back and forth. So that's good enough for hydrogen. But all the other atoms need to have a total of 8. And remember, we talked about shared and unshared. So when you add up all the shared plus all the unshared, which you should be good at by now, you should always get 8, unless you're hydrogen. And then you only need 2. But everybody else needs 8. And you get that by adding all the shared and unshared. The shared are always going to be lines. The unshared are always going to be pairs of dots. So let's do that now. Let's look at a few examples here, and let's see if there's any pictures that we could rule out because all the atoms don't have an octet. So let's look at our first example. We don't have hydrogen, so that means every atom has to have 8. So let's look at this chlorine. We've got 2, 4, 6, and then 2 in the bond. 2, 4, 6 plus 2 in the bond is 8. Over here, 2, 4, 6 unshared, and then 2 in the bond is 8. That looks good. Let's look at this example. The one on the left is 2 dots on top, 2 dots over here, 2, 4, 6, 8. That looks good. This chlorine's got 2, 4, 6, 8. So we've got another option that might be possible. Now let's look at B. We've got 2, 4, 6, 8, 10. This chlorine has 10. And so does this one. But as soon as you realize one of the atoms has more than 8, it is automatically ruled out. Let's look at D. D has 2, and then in the bonds, remember each bond is 2. So we've got 2 here, plus another 2, and another 2, and another 2. That's a grand total of 6 in the bonds. So 2 unshared plus 6, that's 8. That chlorine looks okay. And the one on the right is a mirror image. That also has 6 in the bonds, and 2 over here. That also has 8. So that could be a possibility. So we've at least ruled one out. Now let's look at the next one. Here's some hydrogens. Remember, hydrogen can only have 2. Sulfur is not a hydrogen, so that means it has to have 8. So A, letter A, we could rule out right away because hydrogen has 8 electrons. 2, 4, 6, 8. That's wrong. Hydrogen can only have 2, which we said is just a single bond. So if you ever see hydrogen with anything but a single bond, it's wrong. Like this one. Here we have hydrogen with 2 dots and a double bond. That's wrong. Here we have 6 dots plus a single bond. That's wrong. Over here, C, we have hydrogen with a single bond. That is perfect. That means hydrogen has 2. And over here, that hydrogen with a single bond, that has 2. That's good. And sulfur, remember it's not hydrogen, so it has to have a normal octet, normal 8. So it's got 2 on top, 2 on the bottom, plus 2 in this bond and 2 in this bond, 2, 4, 6, 8. So each hydrogen has 2 and sulfur has 8. This is it. This is correct. And we know it's correct because if we look at D, this can't be possible. This little hydrogen has 2, another 2, another 2, another 2, and another 2. That's crazy. That's 10. Can't do it. So it looks like C is the only one that's possible. Now look at the last one. We don't have hydrogens, so that means everybody needs 8. Every carbon needs 8. Every fluorine needs 8. This picture can be ruled out right away because fluorine only has 2. Doesn't have 8. That's wrong. This picture, We got fluorine with 2, another 2, and then in the bonds, another 2 and 2. 2, 4, 6, 8. That one looks good. This fluorine has 8. This fluorine, 2, 4, 6, 8, has 8. This fluorine, same thing, has 8. So our fluorines all look good. But let's look at our carbon in the center. Carbon in the center also needs 8 electrons. But look at its situation. It has all these bonds. Every bond is 2. Remember, every single time you see a line, it's 2. So we've got 2, 2, 2, 2, 2, 2, 2, 2. That's crazy. 2, 4, 6, 8, 10, 12, 14, 16. That can't be. It needs 8, not 16. So C is wrong. Let's look at B. B, we've got fluorine, 2, 2, 2 plus 2 in the bond. That's 8. This fluorine's the same thing. 6 unshared, 2 shared. 6 plus the 2, 8. This fluorine looks good. 8. This fluorine looks good. 8. All my fluorines look great. Now let's look at the carbon in the center. It's got 2 in this bond, 2 in this bond, 2 in this bond, and 2 in this bond. 2, 4, 6, 8. Carbon looks great. So everybody is good. This could be a possibility. Now let's look at D. D, we see 2, 4, 6, and then in the bond, another 2 and another 2. 2, 4, 6, 8, 10. Right away we see something that doesn't have an octet. It has more. D is wrong. So the only option left that's correct is B. So we figured out what the correct answer is for number 2 and for number 3 by first figuring out the total number of electrons and then looking to see who has an octet. We know for number 2 that the only possibility is C. I believe model C correctly represents how the atoms in this molecule bond together. What we need to do now is verify how many electrons are actually in our model and how many electrons each atom has. So this involves a little bit of counting. So you have to count the grand total number of electrons in the entire model, and you have to check to see that it matches this. And if it does, you're correct. So this bond is 2. We got 2 electrons on here. This bond is 2 and another 2 electrons here. 2, 4, 6, 8. There's 8 electrons total. They're all being shared, but there's 8 electrons total. And then you have to verify who's got what. This little hydrogen has 2 electrons. This dot represents, or the circle represents where hydrogen is. Then there's a single bond. That sulfur has 2, 4, 6, 8 because it has all those electrons. So sulfur has 8, and this little hydrogen shares just those 2 with a single bond. So this is proving, B is proving, that each one of these atoms has their version of an octet by sharing the 8 that we started with. Let's look over here. We decided B is correct. So we want to show how many electrons are actually in our picture. And then we want to prove why it's correct. We want to prove that everybody's got their octet. So the easiest way to do this is to just count by 2s. Every time you see a pair of dots, it's 2. Every time you see a line, it's 2. So 2, 4, 6, 8, 10, 12, 14, 16, keep going, 18, 20, 22, 24, 26, 28, 30, 32. Now, I don't care how you count, as long as everything is accounted for. 32 electrons are present in model B. Now, does everybody get their octet? And the answer is yes. You have to prove that everybody managed to get 8. So, this fluorine has 6 plus 2 in the bonds. This one has 8. This fluorine up here has 6 plus 2 in the bonds, 8. This fluorine has 6 plus 2 in the bonds, 8. And down here, fluorine has 6 plus 2 in the bonds, 8. And then don't forget about your center atom. Carbon has 2, 4, 6, 8. Carbon makes all these single bonds, and it has 8. So we took 32, divided them up, shared them so that everybody gets 8. And think about this real quick. You have 5 atoms here. You know 5 times 8 is 40. We didn't have 40 electrons. We only had 32 electrons. But this picture shows the way that they have to be shared so that everybody can still get 8. All 5 atoms can still get 8 with only 32, not with 40. Now, let's go back to the first example here. We've got 3 possibilities. We decided it could be A, it could be C, or it could be D. So which one is it? Well, this is where we have to go to step 3. We want to check to make sure that the total number of electrons in the entire model matches the number of valence electrons that you tallied in step 1. So we tallied 14. Let's look at our model and figure out which one has 14. And that'll tell us, is it A, is it C, or is it D? Let's start with D. D, we have 2, and then 6 in the bonds, and then another 2. 2 plus a 6 in the bonds plus 2 is 10. 10 is not 14. It's not D. Over here, we have 2. Let me get rid of all this mess here. Okay. So we've got 6 out here. Oh, I'm sorry, 4 out here. We got 2 and 2 plus 4 in the bonds. Double bond is 4 electrons plus another 2 and 2. So add this all up. 2 plus another 2 is 4 plus 4 is 8 plus another 4 is 12. 12 is not 14. So it can't be this one. It's not C. Let's check to see if it's A. It should be, because that's our only option left. But let's see. We've got 2, 2, 2 plus 2 in the bonds plus another 2, 2, 2. So let's count. 2, 4, 6, 8, 10, 12, 14. Hey, 14 is 14. It matches. Our answer's A. So we know it's A. There's 14 electrons present in the model, and each atom has an octet. Each atom has 8. We know that this chlorine has 2, 4, 6, 7, 8 in the bonds. So this one has 8. And this chlorine has 2, 4, 6 plus 2 in the bonds. 8. They both have 8 with that single bond in the middle. And again, you have 2 atoms here. 2 times 8 is 16, but that's not how many electrons we had. We only had 14. They just had to be shared in a way that gave everybody 8. So covalent is all about being creative. How do you take 14 and come up with enough to give each 8 to make up for the 16? How do you start with 8 and end up with 2 for this one, 8 for this one, 2 for that one? 2 plus 8 plus 10 is 12. But yet they only had 8. Over here, we only had 32, but yet we gave 5 atoms each 8. We made up for the missing electrons by sharing them in a certain way. And it happens to be by picture B. So we're going to do more practice with this, but these are the general steps you take. Come up with that total, and it's important you do your math right. Then you just want to check to see if everybody has an octet. And if you have more than one answer left, then you have to see which one matches the total number of electrons that you started with in step 1. That's going to be your correct answer.